Graphical representation of a motion. Today I am going to discuss this concept. Graphical representation is very useful and convenient method to express the data. You might have observed that the cricket score on a graphical representation. By seeing that graph itself, you can understand many things. The scores of the different teams, the runs of the teams at different overs. So a lot of information you can get it from your graphical representation. So here the motion of your object also we can describe on a graphical method. Before that, we need to know some basic points in graphical representation, and that you have two axes. One is x-axis and one is y-axis. Which type of quantity we need to take on x-axis and what quantity you need to take on y-axis, that is important. Always the independent quantity between these two should be on x-axis and the dependent quantity should be on y-axis. So independent quantity should be on x-axis and dependent quantity should be on y-axis. So remember these points. Now have a look once how to represent the distance time graph. Distance time graph. If object is at rest, how we can represent that position on a graph? Already we discussed what is rest means. If the position of the object is not changing with respect to time and reference, that means the position of the object is fixed, it's not changing with respect to time, then we will call it a rest. Take an example here. Object at my observation, initially the object is at 0 seconds. It is at the distance of 4 meters. Now after 2 seconds also the object is at the distance of 4 meters only. At the 4 seconds also object is at the distance of 4 meters. At the 6th second also object is at the same distance of 4 meters. That means what happened here? Here the time is increasing even though the position of the object, the distance from reference to that object, that is fixed, that is 4 meters only. If we represent this data on a graph, what type of shape you will get? Have a look once. Here you see once, this is a 0, 0 horizon and time I have taken on x-axis because the time is an independent quantity as we discussed, and the distance is dependent quantity. That's why time is on x-axis and the distance is on y-axis. Now at the time of 0 seconds, that means when I started my observation, the object lies at the position of 4 meters. So this is the position of the object. When object at 2 seconds also, the object is at 4 meters only. That means at 2 seconds also, object is at 4 meters only. At 4 seconds also, object is still at 4 meters distance. At 6 seconds also. So if you join these points, so what type of graph you got here? Yes, it's a straight line. And parallel to the time axis. It's a straight line and parallel to the x-axis. That means if the object is at rest and you are representing that on distance and time graph, you are getting the straight line passing parallel to the x-axis. So the graph of distance time for the object at rest is parallel to x-axis. Parallel to the x-axis. We will observe the shape of a graph for an object under uniform motion. What does uniform motion means? If the object covers equal distances in equal interval of time, then we will say it is under the uniform motion. Take an example here. Look at here. When the time is increasing from 0 to 2 seconds, 2 to 4 seconds, 4 to 6 seconds, the time interval is constant here. And the distance covered, if you observe here, initially the object is at horizon, that means 0 meters. Next, within the 2 seconds, it reached to the 4 meters, and within the 4 seconds, it covered the distance of 8 meters. Within the 6 seconds, it covered the distance of 8 meters. If you observe here, the time gap is 2 seconds. In the equal interval of time, the object covered the equal distances, that is every time 4 meters. Here also 4 meters, here also 4 meters, and here also 4 meters. If you represent this on a graph paper, what type of shape you will get, you will observe. Initially, the object is, my observation, the position of the object is at rest, that means here. This is. Within the 2 seconds, it covers a distance of 4 meters. From 2 seconds, it is at the distance of 4 meters. Within 4 seconds, it is at 8 meters distance. Within 4 seconds, it is at 8 meters distance. Within 6 seconds, it came to the distance of 12 meters. So, if you join these points, so what type of graph it is? It's a straight line. And passing through the horizon. That means the uniform motion of the object, when you are drawing between the distance and time, the shape of the graph is a straight line and passing through horizon. So it is a straight line and passing through. From the distance time graph, if you find the slope of a graph, what you will get? In a uniform field condition, I am going to observe that what is the slope of the graph gives. What is the slope formula? Slope is nothing but it's the ratio of the change in y component to the change in x component. Here, what is there on the y-axis? Distance. That means change in distance. And what is there on the y-axis, x-axis? Time. That means change in time. The meaning of the slope in this condition is change in distance to the change in time. So that means simply if you are writing that, we can find distance by time. That means what is the meaning of distance by? Is it the meaning of rate of change in its distance? What you will call that rate of change in distance? Yes, speed. That means slope of distance time graph gives us speed. Non-uniform motion or non-uniform speed. What is nothing but non-uniform speed? If object covers unequal distances in equal interval of time, then the motion is non-uniform. Here I took similar example. Here the object covers equal intervals of time. Object covers unequal distances. Here you can see that the gap between the 4 meters here and between these two is only 1 meter, and between these two only 5 meters, but the time intervals are equal. That means object covered unequal distances in an equal interval of time. If you represent on graph, what type of shape you will get? Have a look. Initially, the position of the object is at horizon. So at the time equal to 0 seconds, the position is here. When time equals 2 seconds, the position at 4 meters distance. This is the 4 meter distance. At the 4 seconds, it is at just 5. This is the 4 meters, and just here I am taking as a. So this is the position. And at a 6 seconds, it covered the 10 meters distance. This is the 8. So here it will be the 10. If you join these points, so what is the shape of? Is it in a straight line? No, it's a curve. That means if it is a non-uniform speed or non-uniform motion, the shape of the graph between distance and time is a curve. It's a curve.